Hello again. Let's continue with our course. So now let's cover the following. So what are artificial neural network? Give some historical overview and look at their applications. So there are different definitions for artificial neural networks. I try to give a formal one. So artificial neural networks are a type of artificial intelligence that attempts to imitate the way a human brain works. So rather than using a digital model in which all computations manipulate zeros and ones, and neural networks works by creating connections between processing elements. As we're going to see, they're called neurons, and the computer equivalent of neurons, okay? Artificial neurons, we call them in the case of artificial intelligence. And the organization and weights of the connections determine the output. So your information is stored in the way the connections are done, and also in the weights of these neurons, as we're going to see. So another way of looking at what artificial neural networks are. So their hardware is powered by biological neural networks. So you're trying to imitate the human brain. They are parallel distributing computing paradigms. You can say that they are algorithms which learn by examples in the case of supervised learning. They are tolerant to errors in data and hardware. So even if you have, for example, as we've seen in the case of auto-associative memories, so even if you have an incomplete input, so your system is tolerant to these errors. And it's also, you can say that artificial neural networks are example of a complex system built from simple parts. These parts are simply neurons. So some historical overview. So in the 40s, 50s, and 60s, so McCulloch and Pitts in 1943 came up with the threshold neuron. These guys are generally recognized as the designers of the first neural network. In 1949, Hebb came with the first learning rule. This is called the Hebbian rule. We'll look at it later. Rosenblatt in 58 came with the perceptron and the learning rule. Okay, so we're going to talk about perceptron and the multi-layer perceptron, fully connected network as it is referred now to in the deep learning literature and so on. And then Widrow and Huff came with Adaline, adaptive linear unit. We're going to talk about it also. So that was up to the 60s. In the 70s, Minsky and Popper in 69 came up with limitations of the perceptron. As we're going to see later, they showed that the perceptron cannot work for an XOR case. So it works for the AND OR, but then it is not able to learn decision boundaries for the case of the XOR. So it's not always able to classify, it has limitations. And from there, the interest waned, and then there was kind of the death of artificial neural networks. So the rest of the 70s were quiet years. In the 80s and 90s, in the 80s, there was again an explosion of interest. The backpropagation was discovered. So it started a little bit with Werbos, Parker, and then Rumelhart in 1986 came up or discovered the backpropagation. As we're going to see, backpropagation is an algorithm that is used to adjust your weights, to change them. And then in 1982, Hopfield came with this associative memory, fast optimization. We're talking here about Hopfield networks. Fukushima in 1988 came up with the neocognitron for character recognition. So that's a network based on a model of the human visual system developed by Nobel Prize winners. And then Fukushima kind of adjusted it to the case of artificial neural network and came up with initially the cognitron and then the neocognitron. It was tested on on character recognition. The 2000s, they were quiet years, mainly because of the SVM. And then in 2006, 2010, Hinton came up with the hierarchical feature learning, and then came the CNN, and then there was an explosion of interest in the area of artificial neural networks of deep learning. This is an overview, a historical chart, kind of to talk about this. So as you can see here, McCulloch and Pitts came up with the, here they call it electronic brain. So you can see here the AND function, the OR function, the NOT function, the adjustable weights, but the weights are not learned. And then came the perceptron, and then Widrow and Huff, learnable weights and threshold. So the bias, as we're going to see, and the weights are learned. And then came the Adaline adaptive linear unit. And then the XOR problem killed the whole thing, so for a while. So that's the dark age, AI winter, as they call it. So, so they showed here that, yes, for this case, you can have a classifier. For this case, you are not able to use a linear classifier to classify your, or to solve your XOR problem. And then in the 1986, as I said, so solution to nonlinear problems. So the multi-layer perceptron, the backpropagation came back. There was again some interest in the area of artificial neural network until the SVM came, and then that killed a little bit neural networks until again in 2006 when Hinton came up with you know, a way on how to train deep networks. We're going to talk about what is a deep network. Applications of deep learning. You have a number everywhere now. Deep learning is used from in agriculture, in medicine, but just to have some specific examples. So. So you can use it, for example, in signal processing for adaptive echo cancellation. You cancel the echo in an adaptive way using artificial neural networks. So you make the system learn to cancel this echo in pattern recognition, of course, character recognition, speech synthesis. You can translate the text to speech, i.e. synthesize, and then recognize, speech recognition, speaker recognition. You can use it for artificial neural networks for forecasting and prediction. You can also use them for control and automation. So you can design what is called neurocontrollers. For example, you can have a reinforcement learning for the case of the broom balancing problem, i.e. to balance a broom to make it, you know, stand. And then whenever it falls, you give it a penalty. Whenever it stays, you know, you are excited. And then if it stays straight, then you reward it. So this is reinforcement learning. Radar interpretation of brain scans, MRI, stock market prediction, associative memory, optimization, again, Hopfield networks, and of course, computer vision. And this is our interest. So the taxonomy of, I think we stop here.